Today I will be talking to you about the University of Birmingham campus digital twin. This is a slightly different presentation insofar as that it's not really a research project as such, but it's an initiative that has been developing in the past few years at the university based on the good works of some of our colleagues, and I'm here just on behalf of them to present some of the motivations, progresses that we have achieved so far, challenges that we have faced, and the lessons that we've learned in the journey. So I'll start by just broadly introducing the digital twin and the UOB digital twin, and as I said, I'll present some of the progress, showing some of the benefits, and highlight the challenges towards the end. Whilst I'm pretty sure most, if not all of you are familiar with digital twin, I thought that I'll just remind ourselves that a digital twin is a virtual model of, or a replica of a physical system or model that can be used to simulate the behavior of that system, predict different scenarios, get data from it, and design and optimize it for different purposes. And on that basis, University of Birmingham Digital Twin is no different. This initiative started just before COVID through a collaboration with Siemens that took place around 2020-21, where the partnership between University of Birmingham and Siemens formed. It went then for external consultancy, engagement with the wider sector, and bringing some proof of concept projects and the initial thoughts behind it. I've provided a link to the Smart Campus, which is the project that behind the digital twin of the campus in that link, which if you Google, you can find further data and information about the history of this initiative. So what the Smart Campus is trying to get? Well, it's trying to get data from all the things that are happening across the university. We have a campus in Edgbaston, which is just about 10 minutes train journey from here. But we also have facility across West Midland, as well as overseas. We have a campus in Dubai. And some of these buildings and facilities and infrastructure are modern, of which then they were equipped with the sensing and hardware technology to collect the necessary data, and some of them were updated, maintained, and the technology was added later on. The data then will be used for understanding the behavior of the users, as well as the physical infrastructure as well. And it will then allow the decision makers, the asset owners, the estate of the university, and everyone who benefits from it to take actions to run things better, to make things more optimum, to save energy, and other benefits, which I will highlight later. It also ultimately can be used as a way for allowing researchers, students, to have access to this data to perform academic research on that basis to take things further forward. The campus is rich in data. We have over 40,000 occupancy sensors, either being recently installed in the new buildings or retrofitted to the existing ones. Over 10,000 environmental sensors. We have over 1,000 water and energy meters. And collectively, a lot of events going on, of which we have the records for them. And by events, I mean timetabling for the lectures, staff meetings, and so on. These can also be the data that we can use to feed into our digital twin. So if I wanted to then go into a little bit more details, in addition to those, we also have space and building models, especially for the new buildings where we will be able to use the as it was built models, AutoCAD, if you like to call it, or other formats of the buildings, of which then we can precisely get the size of the rooms, the number of them, potential number of people that could work in those areas. Through the sensors and the meters, we can get occupancy utilization. So it's not just occupancy, but utilization, energy and water consumption as well. Some of our new building, like the one that I spend most of my time engineering building, are fitted with environmental quality, and they're also equipped with the system where the windows can open when the quality of the room drops below a certain threshold to ventilate and provide fresh air. Data for heating, cooling, as well as other formats of data from timetabling, attendance monitoring that we record on certain frequency for monitoring student attendance, and space booking that we do use for staff meeting. Now they come in different formats and types, but they're all useful data that helps us to collect that insight or get that insight about the university business. Potentially, having access to those data and gaining those insights could help us with managing our estates, buildings, and spaces, as well as the infrastructure that supports the buildings better. So as an example, by monitoring the use of those buildings and spaces and shutting them down at certain periods, not just over Christmas, which is the typical, but when we feel that the usage has dropped below what is the standard, redirecting the resources to where we can then better use them. Communicating those data with the timetabling team who looks after the timetabling of all the teachings. These collective efforts can potentially save £1 million per year if we just only limit it to those certain activities. These are just few examples of what we can do. Who works on this project? So it's a team effort. They all have one common goal, but they come from different backgrounds. So they are academics like myself who sit on the panel, but it also involves building management system, people from estate, people from IT, and various other groups who contribute into developing ideas, but also actually getting those data and running it on daily basis. So these are some of the history, some of the thoughts that were behind how we get to the digital twin. What we have actually developed so far includes the conceptual architecture. So perhaps I should have mentioned that some of the things that I will say and present here are more visionary, and not all of the things have been achieved. But a version of this conceptual architecture has been developed, which brings together data from the sensors and energy meters, water and energy meters, as well as which all can be fitted into those blue boxes. And roughly they have similar nature in terms of the data type, together with the different types of data that comes from timetabling, bookings, visitors that come to university on regular basis or otherwise. Plus the data that we get from the Wi-Fi and the devices that connect to those Wi-Fi routers and hotspots. Combining those together, putting them into a middleware platform, with the help of the API, we've developed a dashboard, an app in Autodesk Tandem, which allows us to gain access to the data, but also visualize it in real time or as close to real time as possible. So in the next few slides, I will go a little bit in more details as to what those actually mean and show you a few examples where we have collected those data on the campus. Firstly, what we're hoping to achieve with these data is to reduce energy and costs. I'll show you one example where potentially by just doing those few limited actions, there is space to save £1 million per year. But it's not just that. We're hoping that this initiative, this work, supports sustainability, improve the use of space. I'm sure that there have been many times for those of you who felt that I wish we had more spaces for teaching, I wish we had more spaces for meetings, and this data can help us to realize that whether that's actually the case. Are we really under-resourced for the spaces or not? And in turn, that will also help with the overall campus operation. But it's not just about now, it's also helpful for the future. So the data and the insight that we get from it can help and provide input to the future strategies of the university. The project can be even extended further. So it's not just about a little space within the campus, but can also be extended to the city. And so provides an input to that goal of achieving net zero target by 2050 by having a smart city, part of it being the smart campus. Some of the further motivations and potential benefits of having a smart campus has been published in this paper called Building the Smart Campus. If you Google it, you will find more details extended to what I've just presented. So a few examples of what it looks like. So this is, so the next few slides, I've put together a few screenshots with the help of colleagues from IT, where I can show you that what it looks like. So this is a screenshot of the almost center of the campus. You will see the old Joe in gray. The gray color usually refers to as it's not been digitized, if you like. I don't think that's a great deal for the old Joe. It's a 100-meter long clock tower. It's not going to be used that often, so we can forgive them for that. But for the rest of the building, the different colors basically demonstrate different occupancy or different rate of energy, or depending on the data usage. For a simple map like this, whether be it in real time or whether be it based on the historical data that we collect, we can simply save a lot of energy around the heating and cooling in buildings. We can even help students during the busy times of their exams and readings. That red building that you see there is the library. And the red shows that this has been captured near exam time. So it shows that that building is popular, also being the 24/7 open. And we get a lot of complaint about, well, we have the exams, but there's no spaces to go to, whereas there are other spaces available not known to students. Having information, having insight, having some level of intelligence from this map can help them to direct them towards other buildings where there are spaces for their revisions. I mentioned energy. Again, you can see that popular buildings like library. This one here is the engineering buildings. So the dark color means that they're using more energy. Energy does not always necessarily mean that there is also higher occupancy. This could be because of a particular equipment that drains energy for a certain period of time. Just to give you an idea, University of Birmingham campus annually spends about 66,000 megawatt hour of electricity. To put that in a picture, that's about a third of what Heathrow Airport, all terminals and everything spent in 1 year. So you can imagine that doing a small saving there by just shutting down a building that is only being used by a few people can make a huge difference. A similar example for water profile. So again, using those meters, you can get some ideas about the water consumption across different buildings in the campus. Things are not necessarily at building level. So with these location sensors, we can even go to the room levels, occupancy, and collect information about movement of people as well as the level of utilization for rooms. So this is the Aston Web, which is basically the arch where most of the offices for vice chancellors and others is located. And you can see that which areas are more popular in terms of utilization. Just to give you a feeling that what it looks like, I've asked my colleague in IT, Tim, to do a quick demo of the environment, the digital twin environment that we've created with having those few buildings at the center of this demo. So it's just a short video that he has recorded for us.
This is just a really quick recording to show the University of Birmingham's macro digital twin that has been developed in conjunction with the university's estates team and innovation team in IT services. The point of our macro digital twin, which is created using BIM models of our buildings on campus, is to allow us to connect all of the data, systems and services that we have on our campus against our space in a way that allows us to derive decision making. Lots of the decisions we're trying to make here are trying to improve the use of space on campus, reduce the cost of energy in running campus, and generally approach sustainability through a data-driven means. What this twin allows us to do, using a system called Autodesk Tandem, is it allows us to explore the 3D models, or the 3D model of our campus, which does include every building on our campus. And it allows us to bring data from all of the systems and services that tell us how our campus is being used into a single place. What the system's capable of is it's capable of connecting real-time data to the model so that we can see services in real time. This example hasn't been refreshed in a while because it's a prototype, but we can refresh the data automatically every 5 minutes, so we can see the energy consumption and the water consumption of a building in near real time. We can see the people and the amount of connected devices in a building in near real time, and we can see how much space is available per person in a building in near real time. What we've been doing through our Smart Campus initiative is trying to connect a number of data sources to digital twins so we can use it to drive decision making and improve the operation and experience of our campus. We can also do this in specific buildings, so we can go into specific buildings on campus to specific floors and rooms and look at the sensor data in those specific places, so we can make more intelligent decisions about how we utilize our space, how we occupy our space, how we provide it to others, and how we utilize energy in it. It's just the start, and we hope to do more, but we're really excited about the possibility of using macro digital twins and near real-time data to improve the decision making at the University of Birmingham.
Okay, so that was Tim just highlighting and doing a quick demonstration of the environment for the digital twin of the campus. I've already highlighted some of the benefits, but if I just wanted to extend that, I'm not really sure how does it feel for other universities, but at Birmingham, often we feel that we're really under-resourced for teaching spaces. And this digital twin tool is one of the key tool that we're hoping that help us with making improvement there. Building larger and larger and more of these teaching spaces has proven not to be always helpful. We've built now so many other buildings, and we're still feeling that pressure of the space shortage. Sometimes it's not just about the teaching; it's also about the office spaces for the meetings that we have and for the regular business, day-to-day business that we have. This is a screenshot of the School of Engineering. In the new building, academics share office, so every 4 of us share one office together. And there are also pods that are available to all academic staff for meeting. Managing these around the peak time of meeting students for their academic review has been a very difficult and a challenging task. Again, another example of where this digital twin could be beneficial, where you can get the data in real time and make plans accordingly. Same with lab spaces. So if I just wanted to show an example of what it looks like, here are examples of some of the popular buildings, rooms across the campus. So Muirwood Tower, 420, all the way to the one in medical school. The blue line shows that the frequency of which these rooms are requested to be used per week. For most of them, it's somewhere between 50, 60 to 80%. So it looks as that they are very popular and there's a high demand on them. The occupancy sensor data, however, says differently, that we've collected it over a certain number of weeks. And if we then look at the utilization, which is basically the frequency times occupancy, you can see that immediately we can make things much more efficient with the space utilization. It's not just about the seminar rooms. If we look at the computer rooms, we see a slightly different pattern. And we can make guesses as to why that is the case. But again, different clusters of computer and IT rooms. You can see that for some of those, the occupancy actually goes high. That's because there are more flexibility around IT rooms. So if I teach in an in a computer cluster, I don't mind if others coming in and sitting down doing their simulation as long as they're not disturbing the rest of the class. But that means then suddenly the occupancy goes up. So there are different trends. Each of these will help us to learn about the behavior of the students, staff, and again, making better use of the spaces. It's not all about things above the ground. We also have digital twin about things that we put into the ground. So we have a multi-utility tunnel for the Edgbaston campus, and some or part of it is also equipped with different instrumentations and sensings. Again, that gives us insight on the utilities and water supplies and others usage, helping us better maintaining it, especially if there are damages to them, if we need to maintain them, if we need to plan for repairing them. And at a more local space, we've also been able to build our own digital twin. So University of Birmingham is home for another UCRIC facility. It's called National Buried Infrastructure Facility. And this facility opened about 2 years ago. It has multiple labs and equipment, but the big feature of it is it has a large pit, 25 meter by 10 meter by 5 meter in depth, which allows us to then simulate real world or near real world scale of testing for especially buried infrastructure, but also for things above the ground. Ever since that's been open, which is just around coming to 2 years, we have had multiple projects from industry funded to the UKRI ones. And for some of those, we've been able to successfully also develop a digital twin. So in one of the projects where we had, this is the one on the right-hand side, where we looked at potentially testing a recycled material that was used for a sewage and a culvert system. We built a digital twin of that, and we exposed that model to loading similar to that of a HS2. So the manufacturer was looking for understanding the behavior of this particular culvert system under repetitive loading. And again, that gives us some insight about how to design it in terms of the size of it, the locations of it, the thickness, the type of material, and so on. And the idea is that to extend that way beyond this and to have a digital twin for everything that we put on the ground, because to some extent that actually is harder. Keeping track of things above ground may seem to be to some extent under control with the development that we have built with the sensing, instrumentations, more accessibility to the spaces that we can then put in different sensing technology. But things in the ground, especially some of those going back to the Victorian time, having a digital twin of those seems to me very critical. With the rapid urban growth and development, we're now moving towards scenarios where we have potentially those congested areas under urban environment where you can have metro tunnels, utility tunnels, all sorts of things that goes back to 200 years to the modern ones. And the spaces underneath our feet are getting more congested. So having an understanding of what we put in real time, i.e. having a digital twin of those, seems critical for any future development in that area. I would also like to mention, as I said, that the digital twin is not just limited to things that in Edgbaston. We also have another facility on the east of Birmingham. It's called Tyseley Energy Park. Again, the digital twin of that facility is being developed as we speak. I'm almost coming to end, but I just wanted to also highlight that the road hasn't been always smooth. So we have had, and we're still facing some challenges. First of all, is scaling up the data and access and availability. So at the moment, it is my understanding that only a very selected people have access to those data. So for those screenshots and the video, I've had to put a request to be given those numbers and some screenshots. We would like to open it up, but we are limited on some of the resources. This project hasn't been funded through like a multi-million initiative. It's been mostly done based on voluntarily works, academics, contributions, and some of the colleagues in the IT and estates who put their efforts into building those platforms. So building long-term internal expertise who can carry on and taking this forward is essential to continue this. Data quality always haven't been as nice and smooth as I showed you. Sometimes sensors are not responding. Sometimes some old buildings with these thick walls are not just sending the data that we want. So again, challenges on the data quality. And key is long-term funding, which is the underpinning sort of challenge for all of those. And whilst I've been standing here for the past 20 or 30 minutes pretending that I know what's happening, actually these are the people who are behind the digital twin that I showed you, plus a much more broader and bigger team. I'm just only here to represent from them and also update you on the progress that we've achieved so far. And with that, I would like to thank you for listening to my presentation.